Hello and welcome to the RedisConf session on automation for Redis with Kubernetes operators. I'm Miłowski, Product Manager for Kubernetes at Redis Labs, co-presenting with Brad Barnes, Principal Solution Architect, also at Redis Labs. What is a Kubernetes operator? A Kubernetes operator fills the gap between the capabilities and automation provided by Kubernetes and how your software uses Kubernetes for automation of tasks relevant to your software. These tasks might be the installation of your database, the management of it over time, backup, scaling your database, and so forth. So one way to think about what an operator does, and a good analogy, is a thermostat. There's the actual temperature of the room, and there's the desired temperature. And the thermostat has the representation of the desired temperature. It measures the actual temperature and decides what action to take, whether to heat or cool the room. And this is called a control loop. So operators, Kubernetes operators in particular, have control loops. They're called controllers, and they work on a thing called a custom resource. So a custom resource has a custom resource definition, which defines the kinds of settings that you can make. And a custom resource is a particular instance of that, a particular setting for your software. So I'd like a Redis Enterprise cluster with 3 nodes. And the controller reads that custom resource, looks at the actual state of the Kubernetes cluster, and decides what actions to take. So it might install software, it might scale up software, it might change a setting. So it's going to go out there and measure and say, okay, I need a stateful set, and I need some pods, and I need some services, and I'm going to specify them in a certain way with a certain set of tolerances and persistent volumes and so forth. And it's going to change the state of the Kubernetes cluster. And then over time, it's going to continue to watch that cluster. It's going to continue to look for changes in the custom resource, and then make changes in the actual state. If things fail, it's going to make sure that they are restarted if they need to be restarted. If things change, it'll make sure that those changes are realized in the Kubernetes cluster. And there are Kubernetes operators for open source Redis. And there's a number of them out there. We picked 3 of them, Spotahome, Opstree, and Amadeus, and we took a look at them. This is not an exhaustive comparison, but we wanted to sort of see what was out there and what state they were in. And as you can see, they share some common things, like none of them seem to support TLS. They have a variety of support for standalone, Sentinel, and clusters, different versions of Redis. Some of them include, like Spotahome, the ability to sort of deal with anti-affinity and pod tolerances, so that it helps you schedule the Redis instances on different clusters in Kubernetes. Some of them deal with exposing the databases as Kubernetes services. There are metrics interfaces for some, and some of them don't have that. The challenge is that for a variety of these operators is they seem to be in various states of maintenance. Some of them don't have very many updates within the last year, if any at all. The Opstree seems to be updated semi-regularly, but Amadeus doesn't have any updates, and neither does the Spotahome operator. So your mileage may vary with open source Redis. Kubernetes is a major deployment target for Redis Enterprise, and we have an operator, and that is the way you deploy Redis Enterprise on Kubernetes. Our operator manages the installation of Redis Enterprise, the scaling, the day 2 operations, the configuration changes, creation and deletion of databases, and so forth. And there are 2 kinds of custom resources our operator manages, one of which is for the cluster. The cluster rec specifies things like size of the nodes, how many nodes you would like to have in your cluster, and various other settings. And when the operator discovers one of these things, it will go and create the cluster secrets and create a stateful set and the Redis Enterprise UI and API services and metrics endpoints. and deploy a thing called a service rigger, which maintains parity between various kinds of Kubernetes services and databases, and make sure that all of those pieces are running all the time. And if you change some kind of setting and change the number of nodes in the cluster, it will change the stateful set for you and manage the scaling of your cluster. You then go and create a Redis Enterprise database custom resource. The operator will observe this. It will go into the cluster and create the database, and then the service rigger will discover that there's a new database and create the database service. And this allows an application workload to read the passwords and talk to the database service from a Kubernetes standpoint and use their Redis client to do various operations. And from a lifecycle management, if you delete the Redis Enterprise database custom resource, it will delete the database, and if you delete the Redis Enterprise cluster resource, it'll delete the cluster. And so it does all of the operations of lifecycle that you might imagine, as well as health and maintenance and configuration changes. So let's talk about a couple of these. Cluster scale out. So on the left-hand side, you'll see that there is a small little bit of YAML. That is what a Redis Enterprise cluster resource looks like. And at the bottom, I've changed the nodes to 5. It was 3. And the number of nodes in the cluster is represented in a stateful set here. And so when the operator discovers this change, it goes and talks to the stateful set and changes the number of the replicas from 3 to 5. And then once that's happened, the Kubernetes will take over, and the scheduler will attempt to bootstrap new pods on new nodes one at a time. Add the 4th pod and then the 5th pod, and as those each become ready, they'll join the cluster and become available to Redis Enterprise. Similarly, if you go ahead and create a Redis Enterprise database custom resource, the operator will discover this resource. It will talk to the REST API of the cluster, and it will create the database and the database secret. And then the service rigger will talk to the API and discover that, oh, wait, there's a new database. It'll create a Redis database service endpoint service for that database, and then it'll be available to any kind of application. And then similarly, if you go and change any facet of that database or delete it, the operator will maintain that database for you. So there are a variety of things that you would like to see in an operator. And we've taken many of these things into account into our own operator. So in general, if you have a cluster, you would think that the operator would manage your cluster configuration changes, maybe TLS settings, certificates, various kinds of UI, credentials, etc. Scale out, up, and down of your cluster. If you have concept of databases, distinct databases, you would want to have database creation or replication. You would think of cluster and database recovery as a fundamental aspect of managing the health of your deployment. Health checks are integral to Kubernetes. Things accessing data services is through services typically in Kubernetes. So you have service management, you have ingress and egress management. You may have ecosystem components that you want to integrate with, like Vault for secrets, workload access control for things like, how does this application workload talk to the database? Where does it get its credentials from? You may want to separate the management of your cluster from the consuming applications, and then use different namespaces in Kubernetes for that. And you want your operator to be cognizant of that. If you have secrets that you want to manage, you may want to pull those secrets from Vault or some other system, some other mechanism, or use Kubernetes secrets, and you want that to be managed by the operator. Upgrades, right? When there's a new version, we'd like the operator to have a way for it to be upgraded, and then for it to upgrade your cluster and your databases. And then that's an aspect of the full cluster and database lifecycle. Hybrid cloud situation, you may have different integration points. There may be ingress management to be able to manage the cloud replication. You have platform lifecycle integration, so things like OpenShift have the OLM. You may want to utilize that for managing subscriptions to operators and new versions. There is backup management, the credentials for backup and various kinds of workloads. And RBAC is another mechanism of Kubernetes for access control. You have licenses that are coming from somewhere, and you have marketplaces that allow you to deploy and subscribe and pay for the software that you're using. And those are also things that you would like the operator to do. So all of these things are various kinds of tasks that you want your operator to be able to do for you, whether it's an open source operator or whether it is a Redis Enterprise. So let's see our operator in action. I'm going to turn this over to Brad Barnes.
Thanks for that, Alex. So next we're going to go into our demonstration. In this, we're going to show you our operator in action. First, we'll deploy a Redis Enterprise cluster on OpenShift. We'll show the environment before deployment, after deployment. We'll create a database, and we're also going to create a workload against that database and have a look at some of the metrics, some of the endpoints, and some of the tools we use along the way. Let's have a look at the environment that we're going to use for this demo. So first things first, look at some of the resources in the cluster. So you see we do already have the operator deployed. It comes up as a deployment in a replica set, and there's just one pod serving this function at this time. We can also go look at the OpenShift console. You can see we do have the details. We do have this Redis Enterprise operator deployed in this namespace. We do not have any Redis Enterprise clusters deployed. This window over here will represent that when we do get up and running with our deployment. A couple other useful things in this environment here. We deploy a couple CRDs. So let's have a look at which ones those are. These should be the Redis Enterprise cluster and the Redis Enterprise databases, because within one Redis Enterprise cluster, we will have or host many Redis Enterprise databases. We can have a look through or just step through one of those specs here. So let's do that. Let's get the details of the CRD. This is the Redis Enterprise cluster. It is here for your reference. We're not going to go through any of these in great detail at this point in time. So with that, we'll exit out. So now we're going to deploy our Redis Enterprise cluster using the operator. Here are some of the specs that we've added to our cluster manifest. We're going to name it East Res. We're going to provide an initial username and leverage a GP2 storage class. We're going to use 3 nodes of these particular specs here. And we're also going to leverage an active-active spec, which this is a shortcut for me allowing this API route to be created. So let's go ahead and deploy this. We'll also watch some of these pods be created in the background. We can see here now the second Redis Enterprise pod is now being created. The other thing that we have, this is the second Enterprise pod here. The other thing that we have deployed here is the services rigger. That's this component down here. This is what's going to be the glue between the Redis Enterprise database and the Kubernetes service that is deployed, so you can leverage that service rather than a node port or something like that for your database access. While this final pod is being created, we do already have our user interface route. So let's have a look at what that looks like. So we can log in here. You'll notice that this is indeed leveraging the OpenShift cluster that we've just created. And this is a route that was created as part of the deployment. And this secret was created and generated also as part of this deployment. So this is the Redis Enterprise UI. It's not the purpose of this demo to show all the ins and outs of this user interface, but you can see here, as this deployment progresses, we still do not have our 3 nodes. Those are indeed coming up here. So our cluster is now up and running with the full 3 nodes that we did declare. Another view of that outside of the Redis Enterprise UI is we can see that these pods have been created. I don't think we really need this window anymore. We can also see that all the services and resources created through the command line. So we did indeed create this API route, which we won't use this for this demo, but it is extensive and pretty powerful to leverage. We did use the UI route for accessing the Redis Enterprise UI. You can see we do have our 3 requested, 3 delivered Redis Enterprise cluster in the stateful set, and these pods up here that make up the Redis Enterprise cluster. The same thing is reflected over here in the OpenShift console. So now we're going to deploy our Redis Enterprise database. Let's have a look at what that manifest looks like. The database controller is deployed as part of our operator. We're going to leverage this manifest to create the database. We'll name it here appropriately. This is relatively small in memory space. We are going to use high availability and distribute the workload across 2 primary Redis shards. There are many other parameters you can specify in here. We'll share a link at the end of the presentation where you can find what all those look like. So now let's deploy it. So I think that's done, and you can see here indeed there is a database service that was deployed with the name that we decided over a specific port. There's a cluster IP service as well as headless service. The next thing we're going to do is deploy a workload against this database. So here I have a manifest that describes Redis benchmarking tool. This is using memtier benchmark. We have a couple of standard parameters that we've provided and some resource limitations. We're also using the Redis Enterprise database secret that was created as part of the database controller, so we don't have to copy and paste anything in here to deploy this workload. Let's run it. This database is deployed. Now we can see it back in the Redis Enterprise user interface here. We can also see that the benchmark workload is operating in this namespace that we're leveraging. So let's look at the Redis Enterprise metrics through the Redis Enterprise UI. Sizable workload, really reasonable response time, many metrics we can leverage here for capacity planning and performance monitoring. Redis Enterprise also comes with the metrics exporter. It's already deployed, and we already have a Prometheus scraper and Grafana UI deployed here. So let's have a look at what that looks like. Clicking over to Grafana, we have a couple dashboards. We're going to flip over to the database dashboard and leverage the one that we've currently running workload against. This is it here. This is continuing to update. Some of these will look very similar to what we saw in the Redis Enterprise UI. So this is another service, the metrics exporter, which is deployed automatically with our Redis Enterprise software via our operator. So the last thing we're going to do here is flip over to Redis Insight, which is a GUI for a developer to leverage against a Redis Enterprise or any other Redis service. So this is Redis Insight. It's also deployed inside OpenShift here. It's in a different namespace where I keep all the metrics tools like Prometheus and Grafana. But you can see we have all sorts of information about our Redis Enterprise database. We can also have access to a CLI here or leverage the data element browser here and all sorts of kind of advanced functionality. Let's take a last quick run through with respect to the resources that are deployed here. We have our enterprise cluster that's deployed across 3 pods. We have our services rigger, which is connecting our databases to a Kubernetes service. We have our benchmarking workload, which we've just deployed and have seen the metrics flow through Prometheus to Grafana, as well as in Redis Insight and the Redis Enterprise UI. This is the Redis Enterprise UI service. Here we can see the service from which metrics exporter is running. We also have 2 routes here our API route and our user interface route, which we leveraged earlier. And finally, the replica set listing the deployments and the stateful set, which we can deploy many more Redis Enterprise databases from.
Takeaways. So operators provide a way to automate various kinds of day two operations, as well as installing your software in the beginning. Our Redis Enterprise operator provides automation for many of these tasks. And if you'd like to know more information about our operator, you can look at our platform documentation, and we have some reference material on GitHub as well. Thank you for attending.
With that, we hope you enjoyed our talk. Thank you for attending, and hope you enjoy the rest of RedisConf.